Welcome back. This is an Aleks study video on understanding how molecular collision rate scales with temperature and volume. So the molecular collision rate is how fast that molecules slam together. So if you've got a big jar of molecules, if you've got a tank full of gas molecules, they are in rapid bumping around on the inside of that tank. They're banging off the walls, they're banging into each other, they're like pool balls or bouncy balls everywhere. The warmer that the temperature is, the more energy that molecule has, the faster it's going to move, and the faster it's going to move, the more frequently it's going to slam into other things and into the sides. So if you're looking at the rates of collision, you would say that they would happen more frequently when it's hotter. The hotter it is, the more frequently they're going to slam, and so the rates would be more per second. Okay, you would slam into each other more times per second. The other thing that would do it is if it was crowded. The more crowded you can make that room, the more likely they are to slam into each other. Okay, so density, you want it to be more dense. Now you can do that a couple different ways. You can add more moles. Okay, more moles of gas. Now in this example, all of them are the same. You've got all the same, they're all xenon, and they're all 0.8 moles. Okay, so that's not making it crowded or more crowded because they're the same. But if you could make the room smaller, the same number of molecules would be more crowded. Okay, so the more crowded you can make it, the more frequently it'll slam. So you're looking at two things. The hotter the temperature, the more frequently they slam together, and the smaller the volume, then the density is higher, and the more frequently that they'll slam together. Okay, so they're asking to put 1 as most, and then 2 as next most, 3 and 4 as the least. Okay, well, what would be the most? The most is with the highest temperature and the most crowded, and the most crowded means the smallest volume. Okay, the room is smaller, so it's more crowded. Well, that's going to be, you've only got two volumes, 33 and 30. The smaller is 30. Okay, so that's more crowded. The 30 is more crowded than the 33. And negative 99 is hotter than negative 125. All right, so this number 1 will be most. Okay, what's the next one? The next one is still going to be the smaller room, a little colder. Okay, so this would be 2. So what's the next? Okay, the next slowest. Okay, the next slowest is the same temperature, but a bigger room. Okay, so this would be 3. And then the coldest temperature and the biggest room would be the least. Okay, so they're going to ask you different questions, but essentially you're looking at temperature and density. All right, thanks.